Welcome to a peaceful exploration of the cosmos, where the vast mysteries of space unfold gently before you. This collection of astronomical facts invites you to drift through the universe's most fascinating phenomena, from ancient starlight that predates Earth itself to the invisible dark matter streaming silently through your body as you rest. Whether you seek wonder before sleep or simply wish to contemplate the quiet majesty of existence, these cosmic truths offer both knowledge and serenity. Let your thoughts slow, your body relax, and join us on a journey through black holes, distant galaxies, and the profound connections between the universe and ourselves. The universe is approximately 13.8 billion years old, a figure derived from measurements of the cosmic microwave background and the rate of universal expansion. However, not all observational methods align perfectly. Some ancient stars and galaxies appear older than this estimate allows, while others question the assumed expansion rate or suggest that dark energy may be changing over time. These unresolved tensions hint at a possibility. Perhaps the universe is older than we thought, or what we consider the beginning was merely one chapter in a longer, stranger story. The oldest light we can detect comes from 380,000 years after the Big Bang. Before this moment, the universe existed as a glowing fog, so hot and dense that light could not travel far without scattering. As the cosmos expanded and cooled, atoms formed, the fog cleared, and light suddenly moved freely. This ancient radiation, known as the cosmic microwave background, remains detectable today. The photons we observe have traveled for more than 13 billion years, stretched by expanding space into long, cool microwaves, a faint but ever-present glow carrying memories of the universe's earliest clarity. The phrase "before the Big Bang" may not make sense. According to general relativity and most cosmological models, time itself began with the Big Bang. That moment marked not just the birth of matter and energy, but the beginning of space and time as we understand them. Asking what came before resembles asking what lies north of the North Pole. Some theories propose a previous state or universe, while others describe a quantum realm where time behaves differently or does not exist at all. Not all planets orbit stars. Rogue planets float alone through the galaxy, unbound and without a sun to warm them. These worlds may have formed normally before being ejected from their star systems through gravitational chaos, or they might have formed independently like failed stars. Astronomers estimate billions exist in the Milky Way, perhaps outnumbering stars themselves. Each is a silent world, drifting in darkness, experiencing no sunrises or sunsets, only endless night broken by distant starlight. When astronomers map galaxy positions across enormous distances, a surprising pattern emerges. Galaxies cluster along thread-like filaments with vast empty regions, cosmic voids between them. This interconnected structure, stretching billions of light-years, is called the cosmic web. Remarkably, when viewed at sufficient scale, this structure resembles a neural network like those found in the human brain, with dense nodes of galaxies acting like neurons and filaments serving as connecting axons. In regions where gravity is especially strong, near massive galaxy clusters, space-time itself curves, bending the path of light. This gravitational lensing can create multiple images of the same distant galaxy from different angles, appearing as arcs, smudges, or complete rings called Einstein rings. In rare cases, astronomers observe the same supernova multiple times as its light arrives through different gravitational routes, a quiet reminder that even light can take longer paths and still find its home. The universe's first stars, called population 3 stars, were unlike anything we observe today. Born from pure hydrogen and helium left after the Big Bang, these massive hot stars likely formed with hundreds of times the Sun's mass. They burned through their fuel quickly, shining 1,000,000 times brighter than our Sun, then collapsed in spectacular explosions after just a few million years. Though none survive today, their brief lives changed the universe, creating the first heavy elements, seeding galaxies with light, and setting the stage for everything that followed. Not all stars shine with steady light. Variable stars pulse, shimmer, or dim and brighten in rhythmic patterns due to internal pressure waves, surface eruptions, or eclipsing companions. Some complete their cycles in hours, others in years. These variations are remarkably consistent, acting like celestial clocks. Astronomers use them to measure cosmic distances. A single flicker repeated over time can reveal how far away a star is and its true brightness. When stars like our Sun die, they shed outer layers and leave behind a core, a white dwarf. Some white dwarfs consist mostly of carbon, which under immense gravitational pressure may crystallize. In other words, some stars become giant diamonds about Earth's size, but far heavier, glowing faintly with leftover heat. These stellar diamonds no longer fuse atoms, but continue shining for billions of years before cooling to blackness. Neutron stars are collapsed stellar cores, incredibly dense remnants left after supernova explosions. Only about 20 kilometers wide, their mass exceeds the Sun's. Matter inside is so densely packed that a single teaspoon would weigh billions of tons. A raindrop of neutron star material would be heavier than Mount Everest. Magnetars, a type of neutron star, possess magnetic fields trillions of times stronger than Earth's. These fields are so powerful they could erase data from thousands of miles away, distort atomic structures, or tear matter apart. Single magnetar flares, even from across the galaxy, can be detected on Earth. Black holes don't just trap light, they warp space-time itself. As you approach the event horizon, space bends inward and time slows dramatically. To an outside observer, time near a black hole appears to crawl. At the very edge, it almost stops. Inside, all paths lead toward the center, the singularity, and inward becomes a direction in time, not space. According to physicist Stephen Hawking, black holes can emit faint Hawking radiation. At the event horizon's edge, virtual particle pairs occasionally result in one particle escaping while the other falls in. Over incredibly long timescales, this slow energy leakage can cause black holes to shrink and eventually evaporate completely. For a sun mass black hole, this process would take more than 1 trillion years. Not all black holes reside in galaxy centers. Some roam through space, ejected from their birthplaces by gravitational interactions or kicked out during galactic collisions. These rogue black holes are difficult to detect since they emit no light unless passing through gas or pulling on nearby stars. They drift through darkness, unseen and unbound, carrying no orbit, no companion, no home, just mass, motion, and deep gravity. Most matter in the universe doesn't shine. It neither emits nor reflects light. This invisible substance, dark matter, has never been detected directly, yet we know it exists through gravitational effects. Galaxies spin faster than they should. Light from distant objects bends more than expected, and clusters hold together with more strength than their visible mass allows. Dark matter constitutes more than 5 times the amount of ordinary matter, serving as an invisible framework holding everything in place. As you rest, dark matter flows silently around you. It doesn't interact with light, doesn't reflect, emit, or absorb it, but it has mass and responds to gravity. Our galaxy is surrounded by a vast dark matter halo, and as Earth moves through this halo, trillions of dark matter particles pass through every square centimeter of your body each second. They don't collide with your atoms or leave traces, but they're there, ghost-like, ever-present, and essential. Without dark matter, galaxies wouldn't hold together, and cosmic structures wouldn't form. When you observe a galaxy several billion light-years away, you're not just seeing distance, you're seeing age. The light from that galaxy began its journey long before Earth existed, before the Sun formed, before our solar system took shape. Some galaxies we observe today sent out their light over 10 billion years ago. That glow crossed expanding space, stretched and reddened along the way, until finally reaching our telescopes. The James Webb Space Telescope was built to look farther than ever before, and in doing so, it looks further back in time. Recently, astronomers using Webb identified light from a galaxy existing just 200 million years after the Big Bang. That light has traveled toward us for more than 13.5 billion years. Some galaxies Webb observes may no longer exist in the forms we see them. They may have merged, faded, or changed entirely, but their light is still arriving, snapshots frozen in time, crossing space long after the sources have transformed. Most galaxies are so distant that even powerful telescopes reveal only faint smudges. However, there's one you can see without any equipment, the Andromeda Galaxy. On clear, dark nights in the northern hemisphere, it appears as a soft, hazy oval, visible to the naked eye. It's over 2.5 million light-years away, meaning the light you see began its journey long before humans evolved. Andromeda contains 1 trillion stars, more than double the Milky Way's, and is slowly moving toward us. You can look up and see an entire galaxy with no telescope, just the sky, your eyes, and the soft glow of something vast and ancient.
Every year, the Moon drifts approximately 3.5 centimeters farther from Earth, roughly the rate at which fingernails grow. This slow retreat has continued since the Moon formed around 4.5 billion years ago. Back then, it was much closer, and a day on Earth lasted just a few hours. The cause is tidal friction. As the Moon pulls on Earth's oceans and Earth spins beneath them, a small energy transfer gradually pushes the Moon outward in its orbit. Deep inside the Sun, sound waves ripple through plasma, bouncing between layers and setting the entire star into subtle, continuous vibration. These aren't sounds we hear, they're pressure waves, low and slow, far below human hearing. With sensitive instruments, scientists detect them and use them to study the Sun's internal structure. This field, called helioseismology, allows scientists to map what happens deep below the surface by observing how the Sun rings like a vast musical instrument. It's easy to picture planets orbiting the Sun in neat, flat circles, but zoom out further and something stranger emerges. The Sun itself moves, orbiting the Milky Way's center at nearly 1 million kilometers per hour. As it moves, the planets follow, not just circling the Sun, but spiraling through space behind it. The combined motion creates a helical pattern, like a corkscrew or twisting ribbon, a dance so vast we never feel it. Right now, the universe is filled with stars, burning, forming, exploding, but this is a relatively recent development. For the first few 100 million years after the Big Bang, there were no stars at all. Since then, star formation has risen, peaked, and slowly declined. We live in what might be called cosmic spring, a time when new stars still form, but less than before, and much more than will come in the far future. One day, the last stars will be born, and after that, the universe will slowly darken. Cosmologists once wondered if the universe would collapse back on itself, but evidence now suggests a different fate: slow, endless expansion. As galaxies drift farther apart and star formation slows, the night sky will grow darker. Existing stars will burn out one by one, black holes will evaporate, and matter itself may decay. The universe will become colder, quieter, and emptier, a state called heat death. Over trillions of years, the cosmos will grow still as energy spreads thin and structures dissolve. Not an end of fire or ice, but of silence. 13.8 billion years sounds like a long time, but if you imagine the entire future of the universe, not just tomorrow or a million years from now, but trillions of years ahead, we're still near the very beginning. Stars are still forming, galaxies still assembling, black holes still shining with the heat of falling matter. Right now, we live in a moment of light, a brief golden season when the cosmos is alive with motion and change. The past is vast, but the future is bigger still.
In certain solar systems with different chemistry from ours, if a planet forms with more carbon than oxygen and pressures are high enough, something remarkable happens: a diamond planet. Astronomers have discovered at least one candidate, a dense world orbiting a pulsar, likely a dead star's remnant. Based on its mass, density, and composition, the entire planet may consist of crystalline carbon. Deep beneath the surface, immense carbon lattices could stretch for thousands of kilometers. Dark matter is thought to be the invisible glue holding galaxies together. Yet in recent years, astronomers have found galaxies that seem to defy this rule, galaxies behaving as if they have no dark matter at all. Their stars move as though only visible matter is present. This unexpected discovery doesn't fit easily into current models. Some scientists think dark matter was stripped away during past collisions. Others wonder if we still don't fully understand what dark matter is. The Milky Way doesn't sit still. Along with Andromeda and dozens of smaller companions, it drifts through space, moving toward a gravitational anomaly called the Great Attractor. Behind this immense concentration of matter lies something even stranger: the dipole repeller, a vast cosmic void stretching hundreds of millions of light years where space appears unusually empty. Together, they create a gravitational tug-of-war shaping our local universe's motion. We're drawn forward by unseen mass and pushed back by the emptiness beyond. Right now, trillions of particles called neutrinos are passing through your body, and you'll never feel them. Neutrinos are incredibly light, neutral particles produced in enormous numbers by the sun, exploding stars, and the early universe. They barely interact with normal matter. They can fly straight through a planet or your entire body without leaving a trace. These particles are everywhere, all the time, silently streaming through space and matter alike at nearly the speed of light. In the cosmic microwave background, there's a patch of sky that's unusually cold, not just slightly cooler, but significantly colder and much larger than scientists expected. This cold spot spans hundreds of millions of light years, and its presence doesn't match the smooth randomness expected from early universe physics. Some think it may be the imprint of a vast cosmic void. Others wonder if it could hint at something stranger, like a collision with another universe in the very early moments of inflation. Of all the astronomical facts, perhaps the most quietly astonishing is this: you are made of stardust. The carbon in your body, the calcium in your bones, the iron in your blood, all were forged in stars, scattered across space, and gathered into life. You are not separate from the cosmos. You are a moment of it made conscious, a flicker of awareness in a universe that otherwise only moves, burns, and cools. In this sense, the universe has grown eyes, and through those eyes it looks back at itself, wonders at itself, and dreams of itself. In the first fraction of a second after the Big Bang, the universe expanded explosively through an event known as inflation. That burst of motion left behind ripples, tiny quantum fluctuations stretched across space. These ripples became the seeds of all future structure, galaxies, stars, planets. They also left echoes we see in the cosmic microwave background as temperature variations. The universe may seem quiet now, but it still carries the memory of that first vibration, like a bell humming softly long after being struck. This journey through the cosmos reveals a universe far more wondrous and interconnected than everyday experience suggests. From ancient light carrying messages across billions of years to the dark matter silently streaming through our bodies, from dying stars that become diamonds to black holes that warp time itself, each fact reminds us of our place in this vast, evolving whole. The universe is full of motion and mystery, but also stillness and peace. As you rest tonight, may these cosmic truths bring you wonder and tranquility, knowing that you are not merely in the universe, but are fundamentally of it, a moment of the cosmos made conscious.